secure collaboration on engineering documents. So just as a bit of a rundown of what we're going to be discussing, first I was going to give a bit of background about PDF Tron and our relationship to a lot of companies in the engineering, architecture, and construction space, and then sort of go down some of the critical issues that we hear about when speaking with these organizations, grouped into three big areas that we hear about. First of all, accuracy and performance, and those are kind of grouped together because there's often a trade-off between accuracy and performance. Usability, because there are specific usability issues that come up in construction and engineering that might not be in other contexts. And then security, because, of course, tautologically, secure engineering collaboration requires security itself. So we're going to discuss sort of where things seem to be today in the industry, from what we're hearing from people, and where we think things might be going in the near future. So just a bit of background about PDF Tron, in case you haven't heard of us. We provide a variety of document processing toolkits, both native and web-based. So these are toolkits that can address document viewing and provide interactive PDF viewing and annotation and form filling, but also our toolkits can address low-level document processing, optimization, conversion, and so on. And again, so we target native platforms, desktop as well as mobile, and web-based systems as well. And so we've been working with many different AEC organizations, including many of the top ones listed here, Trimble, Autodesk, Aconex, Aras, and so on. So why is secure document collaboration important in this space? Why is this a big deal for people involved in construction and engineering and so on? Well, at the core of a lot of what goes on inside of AEC is centered around documents, and specifically 2D PDF documents. So the PDF format is kind of like the assembly language of documents. It's a very low-level format, and it's a format that other kinds of documents can be compiled into. So if you have a CAD document, that might be a DWG file, or you might have an Office document, it's a Word file. These can all be normalized to the PDF format, and then you can address use cases within that format. And so in the engineering space, these tend to be drawings, like engineering drawings, that engineers make up and that might then get used in the field to actually build things. And as well, checklists are used heavily to drive workflow, especially for on-site workers. That often will happen through forms-based workflows like checklists and punch lists and so on. And there are a multitude of other kinds of documents as well, RFIs, submittals, contracts, as well as blueprints and punch lists. And over all of this, security is a big deal, especially here in DC. We have to think a lot about the security of these workflows, and are we keeping engineering documents secret, since those could be used potentially for things that the terrorists might exploit. So we actually gave a quite similar talk at PDF Day 2015, collaborating with PDF. That was a presentation given by my colleague, James Borthwick. And what we were talking about at that time was more about how to move away from ad hoc solutions that most users tend to fall back on, and that we heard people sort of complaining about when they wanted to get control over their document management. So it tended to be much more improvisational, where end users would simply email documents around or use shared folders. And so we were talking about how they can move from a solution like that might use native clients, third-party applications, and manual downloading over to more managed solutions where document control is centralized and where documents are viewed over the web and collaboration happens over the web. So the focus today is on where things stand with those sorts of centralized solutions, and specifically about the challenges we hear about in the AEC space. And so what I'm going to do is kind of go over some of the questions that we commonly hear about from people we talk to. So, and again, the first of these areas is inaccuracy in performance. And a big question in that space is how long until I can view my document? So if I have some sort of document that I need to view, whether it's an engineering document, whether it's a workflow-driven checklist, you know, how long until I can actually view that document? And especially with engineering documents, these can take a long time to render. So an engineering document is typically made up of lots of little small lines, little vector elements, and there may be many, many on a single page, and that can take a long time to render. And additionally, you know, I might get these same engineering documents faxed over to me, in which case the engineering document is just one giant, probably high-resolution image, which also can take a long time to render, to decompress, and to render onto the screen. And on top of that, the entire document might have to be downloaded in full before I can even start viewing it. This is obviously true with things like one-page documents, but for longer documents, especially non-linearized ones that aren't organized in such a way that they can be viewed very quickly when downloading, then I could see potentially a quite high latency before actually being able to view a document. And this is important because a lot of what we're getting through electronic documents in the AEC space is a way to move away from printing documents out and just carrying those around, because that adds a lot of time and expense and so on. So this time until I can actually use the document is a really critical one. And especially for large documents, they can take a long time to download. And if I'm using a solution where I need to convert the document to some other format before being able to view it, so if I need to convert it to SVG or to, say, to XPS, then that additional latency might need to be something that is accounted for, and that would add up until I can actually view the document. And then related to this question is the document actually rendered correctly? So once I actually have the document locally, am I going to be able to see the contents of it correctly? And so here I've shown an example of a misrendered PDF sort of discovered in the wild. And I chose this instead of an actual engineering document because here we can see very obvious misrendering. It's a bit different than an engineering document where these things can be very hard to spot, which of course is quite dangerous because any sort of mistakes in the rendering of an engineering document then could be easily overlooked and not discovered until later in the construction process when it's much more expensive to correct. So here in this document, we see some missing elements, like the writing across the top there, and some of these missing cars. We see some elements actually placed incorrectly here, some content not from the original document at all here appearing in the rendered version. And so as a result, in an actual construction scenario, if I'm trying to build something based upon a blueprint and things that aren't supposed to be there are showing up, or things that I'm supposed to look at but aren't showing up there, you can easily estimate materials incorrectly. So I might buy more than I need to, or I might end up with less material than I ought to have, or even worse, I might build something incorrectly, in which case there are labor costs and so on. And so related to this, sort of a special case of this is, can I zoom in and see all the details of an engineering document correctly? And here, what we have is a document that was rasterized at what would be a normal resolution for an ordinary document like an office document or something like that. But here, at that same resolution, if I zoom in, I can't read these measurements at all. It's very difficult to tell what actually should be constructed here. And here we have a list of instructions afterwards that's just a blur of black text. And so this is a very easy sort of mistake to make. It's very easy to get a document that looks like this. If I have a scanned document that was faxed to me, I might want to take that and downsample it so that it's not nearly as large and it might render more quickly, but then we would end up with this blurriness. And as well, if I have a solution that renders vector data on the fly, if I'm choosing too low of a resolution, let's say I have like a server-side rendering solution that just rasterizes at a single DPI and then sends that down to the client, then I might have to deal with blurry data. And related to this is the question of if I can view a document even if the internet is down. So If the document has been optimized so that I can view it very quickly or view it offline, now that I've got this copy, let's say a low resolution image, am I even able to view that? And this is a big problem because many construction sites actually lack reliable internet access. This is not something that a lot of people might expect, but construction sites are often on the edge of town outside of reliable cell service. Often on a construction site, the only actual internet access is a Wi-Fi router in a trailer that if you're standing right next to, you can get on the internet, but otherwise, you're offline. And so this can really factor into the design of document collaboration systems, since not every solution out there brings the document offline, and some of them rely on server-side rendering of documents into images that then can't necessarily support my document viewing when the internet is not available to me. And then related to that, of course, is can I actually edit the document when I have it offline? So now that I've actually got the document, let's say in some sort of form, that I can view it on a mobile device that a site worker might be using or a subcontractor might be using to fill out an inspection checklist, can I fill out those forms if I'm disconnected from the internet? And also what happens when two users edit the same document at the same time? What happens if these conflict, and if the changes are saved into the document and brought back online, how do I determine which copy is the real copy, the one to keep and the one to continue using within my workflow? So that sort of brings us to another big area that we hear about from people designing these kinds of solutions, and that's around usability and around tailoring the solution to the usability requirements of users in this space. So one of those questions is, can the user interface be customized? Many on-site workers, many subcontractors and field workers are not necessarily the most tech-savvy users in the world. It's not something necessarily that factors into the hiring decisions when one is hiring construction workers. And so it's important to be able to slim down the interface so that it's intuitive for field workers. So, for example, removing too many different kinds of annotation types that just aren't used in construction in those workflows. And also related to that, can I create new annotations that fit my workflow closely? And we've heard about this use case specifically of being able to add different engineering symbols onto an engineering document. So, here we have, this is a bit fanciful, we have biohazard and I think laser hazard and chemical weapon. So if you're on a job site, and you see a chemical weapon lying around, you might want to add the chemical weapon stamp. But this is, or a spill or something wrong, you might want to add your own annotation to denote that this is something to be watched out for. And similarly, the ability to estimate the materials required for a given engineering project is very useful if I have annotations tailored to that. So this is a process called takeoff, so that I can measure the materials. Like I might have a ruler tool inside of my viewer that lets me measure, say, the width of a door, so I know how big of a door to buy. Or, for example, like a 2D annotation tool that I might draw around like a room, so that I can measure the 2D area and estimate the amount of carpet to buy in a room or plaster and so on. And sort of related to this too is, can I integrate these annotations into my existing workflow? So, to drive an engineering project, probably what I have is a workflow system on the back end that lets me allocate tasks, and when a task is completed, then to create a new task based on that. So here in this drawing, we have, theoretically a bridge that someone is taking a picture of and saying, this is structurally unsound. And this often happens with a lot of our customers. They're looking for ways of taking pictures out in the field, of identifying things that look wrong or that need to be done or corrected, and then adding that image onto the original document itself, and having that create a new task in the system, so that someone says, oh, this is something that's wrong, I can see this picture of what's wrong and move forward and correct it. And standard PDF forms as well could drive that process too. So if I check off a box in a form saying, this is done, then that should trigger something in my back-end workflow, so I'm not having to keep track of everything twice, and I've got a single authoritative place where this is stored. And then, obviously related to that, if I'm integrating into my existing workflow, can I integrate into my existing document management? I've already got a large collection of documents sitting, in a central place in my organization. Can I integrate into that, or do I need to do things like store the same document twice? Like, if I've got some DMS, do I need to now bring that into my document viewing solution server side so that the document can be viewed? And additionally, do I need to convert the document before viewing? Because that can lead to much the same thing. I might have the original document in CAD, and I need to now convert it to PDF, and then from PDF over to SVG or some other format. Am I now storing the same document multiple times? Can I convert on the fly to avoid that? And what happens if there are two copies of the same document, just in general? And this kind of always happens if two people are editing a document and then saving the annotations directly into the document instead of separately. So if every edit to the document always goes into the PDF, now if I want to show anyone else the edits that I've made, they need to see the entire document. I need to transfer the entire document over to them. So the last big area that we're going to talk about today that we hear about quite a bit from customers is security. So one of the areas where this comes up is, how do I keep information from being leaked? How do I keep the information from inside of my organization from being sent outside? I might have a worker or someone viewing a document. How do I keep them from sharing that around? These documents, of course, might be very confidential, especially in construction, in governmental contexts. We might want to keep all of that information very secret. And so how do we actually make that happen? Obviously, we might encrypt the documents, but even still, users might share the documents after they've been downloaded. So if users actually have to download a PDF copy locally, rather than getting some other format like an image or something, or SVG or so on. So the users might share that copy after they've downloaded it. And additionally, there's the risk of a user just taking a screenshot of the rendered document. No matter what format you have it in, or no matter what encryption you might have added on top of the document, once it's actually rasterized on the screen, that's kind of a big potential security hole. So you might mitigate some of that, for example, with watermarking to identify the user. And then there's the opposite direction when we're talking about security as well. So not just information from inside of the organization being leaked out, but how do I keep people from the outside from getting to that information? So if a document is cached locally on a user's device, then that's a potential risk of the document itself being stolen, especially if that document is unencrypted. And as well, content might be leaked while in transit. So for example, if I have a server-side solution that renders documents to images, and then I'm just sending image data across the wire down to the client, if it's possible to sniff that traffic, then it's very easy to then see that rendered document. And even encryption over the transport layer won't necessarily guarantee that content can't be sniffed. For example, there have been TLS sniffing holes recently, so that's something to be aware of as well. And then, just as we talked about integrating with existing document management or existing workflow solutions, can I integrate with whatever existing security scheme I already have in my organization? So I might have a DRM system, so that before a document is opened, a security check is made. I might even have some sort of biometric system locally on the device that it would be useful if my document collaboration solution could speak to and could integrate with and check the biometrics of a solution. Here in this image, we have a hardware security module, a dongle sitting on the device, that theoretically a document collaboration solution could come out and check. And mobile device management gives us a locked down sandbox in which to run applications. Can I actually run my document viewing and collaboration solution within that sandbox? And similarly, we might have custom encryption on documents as well. I might have added on my own encryption on top of the standard PDF security schemes, and if I'm deploying some new solution, it could be quite useful to actually still integrate with that existing encryption. So where are we today? Coming back from our previous presentation in 2015, definitely the industry has made a lot of progress along these fronts. So we've seen many different solutions that centralize documents and allow collaboration in a managed way that organizations have control over. But there are a lot of trade-offs that sometimes have to be made. So as we were seeing, there are trade-offs between the loading time and the fidelity. So I might make something load faster by using a lower resolution image, or I might have trade-offs between security and offline usage. If I download the document locally so that I can use it offline, is that opening up a security hole? And so these kinds of trade-offs typically have to go into how one is designing a collaboration system. And what's next, we think, is that in general, these things may be more automatically managed in the future. So we may see the deployment of technologies that kind of balance these different trade-offs for you. And we think a constellation of new technologies will help us in this. So WebAssembly, or the running of code within the browser but at native speeds. So similar to Chrome's Pinnacle solution. And as well, there have been some advances in that. Recently with Firefox came out with a way to make that much more performant in general by doing streaming compilation, where the first round of compilation generates a not as performant executable, and then subsequent compilations happen in the background that make the executable run faster and faster. Similarly, PDF optimization itself can be a big help by reducing the document size without compromising the content, so taking out redundant information and otherwise optimizing the document, subsetting fonts and so on. And as well, the growth in container and scaling technologies that we see from organizations like Amazon with AWS and Lambda as well, where you can very discreetly allocate server-side resources, and container technologies like Docker, which also are a very sort of lightweight virtualization technology, enable you to apply server resources in a kind of low-cost and judicious way. And so these can lead to a lot of hybrid technologies or hybrid techniques that can allow me to that can allow you to tailor to different devices and different clients and different scenarios, and manage these trade-offs between these competing concerns. So, any questions?
Thanks very much, Aaron. Yeah, I'd like to take some questions. If you can try and repeat the question when you get it for.
Okay.
Thanks.
Yes?
In your presentation, you demonstrated errors in rendering.
Mm-hmm.
The presupposition is that you're working within a CAD environment as opposed to rendering something that's been digitized as a raster image.
Well, so the question is, when we're talking about misrendering, are we presupposing that we're dealing with a document with vector data included compared to just an image that's been rasterized? In general, that can be true, but there are some renderers that don't handle certain image types. So, for example, I believe SVG doesn't support efficient monochrome compression. You might get a large document there, but additionally, there certainly could be multiple images within one of those documents that could be misrendered. Yeah?
Question in the back.
What's the scope of usage for these kinds of products in the federal government, the United States federal government?
Could you sort of clarify what you mean?
Okay, how many federal agencies are using your specific kind of products and then other related products?
Mm-hmm.
So the question is, how many agencies are using the products in the engineering, in the 3D PDF space? Am I right?
Or the 2D or the 3D PDF screen?
3D or 2D?
3D.
3D.
Oh, okay, yeah, so we actually don't provide any sort of 3D document rendering. This was more about 2D collaboration. So, yes?
So, now that construction sites are using mobile technology,
Mhm.
and PDF is a fixed figure space, how's the footprint allowing in the zoom levels?
Mhm.
How are people working with that? I mean, has there been any breakthroughs with regarding to zooming into a detailed, small footprint
Mhm.
device?
So the question is about if I have a mobile device that might be a bit underpowered, how do I manage zooming into a large image? And there definitely can be issues with that. For example, if you just send a large image down to a mobile browser and try to zoom into that large image with the browser's built-in zoom, that can actually crash mobile browsers because it will try to allocate this gigantic buffer and then cut out a little bit of a tile to actually show on screen. And so, you know, there are various ways you can mitigate that. One of them might be by breaking things up into tiles server side beforehand, for example. Or managing the upsampling yourself inside of the browser. We mentioned WebAssembly earlier, so you could decompress the image in memory, cut out the area that you want, and then scale that up.
So would that also apply to if I just download the PDF locally, as opposed to doing the web browsing?
Sure. Yes. Absolutely. And you know, that might be a bit easier inside of a native mobile app to manage all of that, and because you're not relying on the browser at all. And that in general can be kind of a useful heuristic to not have to rely on the browser to do things like layout elements or decompress images, but rather to try to manage as much of that in the solutions code as possible, rather than relying on the browsers to render. Yep.
Going back to rastering, what would you say be a typical factor for digital conversion in terms of DPI for
So the question is, what would be a typical factor for conversion?
what's the average, standard out there that one would, maybe instead of average, what would be the minimum DPI that you would set for scanning say an e-size?
Minimum DPI for scanning an e-size document.
So I'm not actually sure what an e-size document, what that size would be.
Very big.
Very big, yeah. So a lot of customers of ours who have gone with rasterization have tended to pick 300 DPI, but I've seen some go with a more conservative 600. But these large images that necessarily result are a big reason why it's a great idea to leave that as vector data whenever possible. Yes?
As a follow-up on the size of the image problem that you showed earlier,
Mhm.
The rendering missing information.
Sure.
How do you rectify that? I mean, we've got on our architecture drawings, we've got lines that are thicker than they should be. You don't want these walls to be concrete walls when you build a building, and it's a big problem. And you're right. You don't notice it until it's out on site.
You're talking about on a scanned image?
No.
Okay.
Directly from Revit, directly from AutoCAD.
So you're getting a PDF with lines that are not reflective of the lines in the source application.
Yeah, so I think with
And
that.
different from each PDF writer. Foxit, Bluebeam, Adobe, all completely different.
Huh. Well, what are you using to rasterize in this case? Yeah, I mean,
Each-
yeah,
Adobe.
yeah.
Foxit, Bluebeam, whatever the PDF driver is.
Mhm.
With the very narrow lines to begin with in all cases?
Are these zero width lines?
Right.
They're, depending on the line weight, they're
Hmm.
everything from zero weight to very, very thick. I mean,
Hmm.
Really?
each line weight is very different, like I said.
Sure.
There's a drywall size and a
Mhm.
concrete size, is much different line weights.
Mhm. So it sounds like you might be dealing with zero width lines, which are rendered slightly differently than other kinds of lines in the PDF format. So with zero width lines, I believe it's meant to be 1 pixel, or it's some width in the output. So you might think about maybe modifying the underlying PDF to give it a specific line width, or yeah, you could test out, I think, different rasterizers to see which gives the best results.
That's what we do. We
Yeah.
just go to different PDF browsers each time.
Mhm.
I believe a couple of applications do allow you to make all line widths 1 pixel. So it reduces the noise and the detailed drawing that may have thick lines associated. You can actually turn all the lines.
I do know that I do know that the issue you're referring to is something that the industry is aware of. I've run into it in terms of an interpolation issue, where the computer has to decide on how many pixels are we going to use to represent this line, and given the zoom level, it becomes ambiguous in a sense. Well, we have to pick 1 or 2, and yet you've shown us something which should be a 1 1/3, right? So. But it's a detailed problem, and one that is worthy of consideration. Other questions?
Okay.
No other questions? Okay, I guess we are in fact at our time. So the next session will start in here in about 8 minutes.